Hello, my name is Zach Willard and I'm with the Cisco Nexus Tech team. Today we will be discussing the Embedded Logic Analyzer Module Tool, or ELAM. ELAM is a tool in the Nexus 9000 CloudScale platform used to trace packets. It captures one ingress frame and generates a report about the frame's journey through the switch. This could include drops, forwarding decisions, software punts, etc. You may want to use ELAM to make sure the Nexus is forwarding a frame properly, or to see if you can find a drop reason in the report. Unicast traffic is ideal for Elam, but it can trace broadcast and multicast traffic too. This discussion is based on the Nexus 9000 CloudScale ASIC Elam document externally published by the Cisco Nexus team. I will be following through the steps of the document in a lab to demonstrate the usefulness of it. Before starting, please refer to the applicable hardware section to see if this video applies to your device. As a general rule, this type of capture can be done on any Nexus device ending in EX, FX, FX2, or C. Here is the topology that we're going to be using for this video. We're going to be pinging between N9K1 and N9K3, sourcing from VLAN 10 to VLAN 20. Then we're going to be performing an ELAM at N9K2 and then reviewing the results. Okay, so let's get started with the ELAM capture. Just for a reference, if you want to pause the video, here is the topology that we're going to be using. We're going to be pinging from 192.168.2.2 from 192.192.168.1.2. Alright. And let's just review the devices that we're going to be using. So N9K1 is a 9336C FX2, as are N9K2 and N9K3. Here's the show IP and brief information for them. We're going to be hosting a interface on N9K1 and then doing inter VLAN routing on N9K2 between VLAN 10 and 20. And then another IP is hosted here. So, to start off, we're just going to start a ping between N9K3 and N9K1. Okay, and this is the traffic that we're going to be capturing on N9K2 using the ELAM tool. So let's go over there. If you remember the topology, N9K3 is connected to N9K2 via Ethernet 1.1. This is the interface that we're going to perform the capture on, since Nexus ELAM only does capture on ingress traffic. It cannot be done on egress traffic. So, let's look at the first part of the documentation. The first step we want to do is identify the ingress interface and then run the show hardware internal TA interface command for that interface. What we want to do is we want to pay attention to the ASIC value, the source ID value, and the slice value. And then we want to enter the debug elam instance. So debug platform internal TA elam ASIC 0. Here we're going to be setting up a trigger to tell us what part of the hardware to look at for our capture. So let's do trigger init, and just for reference, if we scroll down, this is the portion of the documentation that we're at. We're at step 4. We're going to be doing ASIC 0 slice 1. This is because of the ASIC 0 and slice 1 values from the output previously. And then we're going to do blue-A2D 1 and then nselect 6. Just to show you the options, nselect 6 tells us to look at the outer L2, outer L3, and outer L4 headers. If we were doing something like capturing ingress encapsulated traffic, we might consider doing nselect 7 or nselect 9. And then we want to do outselect 0, and then we want to do use source ID. This source ID comes from the previous output as well and is indicated here. So we will be doing a source ID of 0. Now that we've done that, we can set up the filter for the actual packet that we're interested in. So, just to show you, We are at step 5 of the documentation. First, you want to do a reset. Always do a reset. And then do set outer IPv4, and then the source IP that you want to capture. So for us, it would be 192.168.2.2, and then the destination IP of your flow. So 192.168.1.2. And then we want to do start to initiate the capture. Okay, and now we just wait a second, and then we do a report. Okay, so the important thing about Elam to realize is that it's not a traditional packet capture tool. It will only capture one packet and then process a report for it. So if you want to see an updated report, you'll have to reset, set the trigger, start, and then run the report command again. Every time you run the report command, it'll be the same packet that was caught earlier. So, some interesting fields that we want to look at are the incoming interface, the source BD, which is the VLAN, so source VLAN 20, the outgoing interface, dmod 1 and dpid 80, and then the destination VLAN, which is VLAN 10. So far it's right. We also have the destination and source MAC addresses, IP addresses, time to live, whether or not the do not fragment bit is set, and we also have some protocol information. If for some reason this ingress packet was dropped, we might see some drop info here, but since it was forwarded correctly, we do not. So, how do we verify the outgoing interface? Let's refer to the documentation again. If we scroll down, we can verify by looking at this section here. The dmod and dpid correspond to the egress interface. This can be checked with the following command. And then we will use the show system internal ethpm info interface Ethernet 1.3, since we know that that is the expected egress interface. And just for a reference, we know that it's the expected egress because of this diagram here. So let's run that command. Show system internal ethpm info interface eth13, and then we're going to do a pipe include dpid. And if we look here, we see the dmod is 1 and the dpid is 80. That corresponds to the outgoing interface value that we have here in our Elam report, meaning that it did egress Ethernet 1.3 as expected. Thanks for watching the video. For any questions about your Elam results, please open a case with TAC.